So for number one, f of x equals 3 to the x, it's a pretty straightforward one here. We're going to use transformation. So we're going to have the point 0, comma 1. We know that one for sure, and we'd label it 0, comma 1. And then we would have 1, comma base, which in this case would be 1, comma 3 here. So I'd have 1, comma 3, there's my base. And then there is also a horizontal asymptote for every exponential function. So then I would have a graph like this. And this would be, f of x is equal to 3 to the x. That one's kind of straightforward and basic, right? But for this one down here, we have a 4 to the negative x and then minus 1. So the first thing that you would do is you would graph f of x equals 4 to the x. So you'd have 0, 1, and you have 1, comma 4. All right, that'd be the first thing you do. So that's graph number 1. And then it would look like this, okay? So that's what you'd have. And then, of course, our asymptote is still here as before. Then I would use a different color, and I'd go to step number 2, and I would graph f of x equals 4 to the negative x. Now that negative up in the exponent, you should all know, is going to give you a reflection over the y-axis. So this point will go stay there, this point will come here. So I'll have this going on like this. Okay, so this is an exponential, this would be step 2, sorry. And then finally, the last thing I would do is I pick a different color, and like red for example, and then we would say, all right, f of x is equal to 4 to the negative x, and then we would subtract 1, so everything would move down 1 unit. So the asymptote would get moved down 1 unit, this point would get moved down 1 unit, this point would get moved down 1 unit, and you would end up with this graph here, and that would be how you use transformations to do it all.